Let's now take a look at calling conversions. Calling conversions are a standardized method for functions to be implemented and called by a machine. A calling conversion specifies the method that a compiler sets up to access a subroutine. In theory, code from any compiler can be interfaced together so long as the functions all have the same calling conventions. In practice, however, this is not always the case. Okay, calling conventions specify how arguments are passed to a function, how return values are passed back out of a function, how the function is called, and how the function manages the stack and its stack frame. Okay, so in short, the calling convention specifies how a function call in C or C++ is converted into assembly language. Needless to say, there are many ways for this translation to occur, which is why it is also important to specify certain standard methods. Okay, so if these standard conversions did not exist, it would be nearly impossible for programs created using different compilers to communicate and interact with one another. Okay, so there are three major calling conventions that are used with the C language. Okay, and the first one here, I'm inside my GNU Nano editor, and we have the first one, which is called the STD. Let me use uppercases. We have what is known as the STD call. Okay, we have the we have CDECL call, and then we have the first call. Okay, like that. Okay, so in addition, there is another calling convention typically used with C++, and it is known as the this call. Okay, like that. Okay, and there are other calling conventions as well, including Pascal and Fortran conventions, among others. Okay, we will not consider those conventions in this part. Okay, in this entire tutorial. Okay, so there are some few terms that we are going to be using in this part, which are mostly common sense, but which are worth of stating directly. Okay, so for example, the first one we have is called passing arguments. Okay, so passing arguments is a way of saying that we are putting our arguments in the place where our function will look for them. Okay, and arguments are passed before the call instruction is executed. Okay, so let us take a look at another one. It's called right to left and left to right. Okay, so these describe the manner that arguments are passed to the subroutine in terms of high level code. Okay, so for instance, if we had something like this, my function, let me use let's have my function. Okay, my function, and then we can supply two parameters, a and b, two arguments a and b, like that. Okay, like that. This one is going to generate this assembly code. Okay, and when it's going to generate the following code. Okay, if passed left to right. Okay, so let's do this. Push a, and then we can push B, like that. We are using left to right way. Okay, and then we can call our function. Okay, my function, like that. Okay, like that. Okay, so here we are passing arguments using the left to right way. Okay, like that. Okay, and this one is going to also, this one here is going to generate this code down here when we pass arguments in a right to left direction, or when we use that right to left way. Okay, so for example, we use push, we are pushing B, and then we are pushing A, and then we can call my function, like that. Okay, so here in the first case we are using the left to right way, and in the next case we are using the right to left way. Okay, right to left way, okay, like that. Okay, so let's take a look at another concept called the return value. Okay, so some functions return a value, and that value must be received reliably by a function's caller. Okay, and the calling function places its return value in a place where the calling functions can get it when execution returns. Okay, so for example, return values must be handled before the code function executes the read instruction. Okay, so another concept we need to look at is cleaning the stack. Okay, so when arguments are pushed onto the stack, okay, eventually they must be popped back off again. Okay, whichever function is responsible for cleaning the stack must reset the stack pointer to eliminate the past arguments. Okay, so another concept we need to look at is called calling function. Okay, or calling function. Okay, and the parent function that calls the subroutine, okay, is known as the calling function. Okay, and execution resumes in the calling function directly after the subroutine call has happened. Okay, unless the program terminates inside the subroutine. Okay, so we have another one, which is the code function. Okay, this one is the child function that gets called by the parent. Okay, which is the calling function. Okay, and another concept is name decoration. Okay, so when C code is translated to assembly code, the compiler will often decorate the function name by adding extra information that the linker will use to find and link to the correct functions. Okay, and for most calling conversions, the decoration is very simple, often only an extra symbol or two, an extra symbol or two to denote the calling convention. Okay, so but in some extreme cases, notably C++, the this call convention, the names are mangled. They are mangled severely. Okay, so in the next part, we shall take a look at the standard C calling convention. Okay, so here, as you can see, the name declaration here, we have added an underscore has been added to our function name, as you can see. So this is the first declaration we have here. Okay, that's the first declaration. Okay, so in the next part, we shall take a look at the standard C calling conventions.